Welcome back from dinner, everybody. Tonight is going to be our second annual or third annual lightning talks. The way the lightning talk works is, well, you saw this format earlier. It's 5 minutes. Usually we're pretty strict about like keeping you to 5 minutes, but we do not have a full roster of all 12 slots, so we're not going to be super strict about if you run over your time. But I'll give you a 1 minute signal when you're there, and we'll try to keep the transitions quick, but we don't have to be super crazy about that either. So we have 7 signed up for 12 slots, so we have lots of time. First up is Jeremy Rand.
Okay.
Okay,
well, I think I can get started while it's warming up. Surprise, I'm talking about Xcode again. This is the third lightning talk I've given on Xcode. And last year I talked to 8-bit. This year I'm going to talk 16-bit. So GS stuff. I demoed this a couple years ago when I introduced it. And I had C templates for kind of all the kind of basic GS targets. And I now have ORCA-M targets also. So you can do an ORCA-M CDA desktop application. But what I'd like to show is the C desktop application, because I've really extended it. It's a superset. It's more involved than the ORCA-M one. So here, let's give it a name. And oh, look, I can select the desktop resolution right here in the project, right at the start. And I can choose to support or not support Message Center, which is like opening files from the Finder, right there. So do that, put it here, and here's our project. And there's more code. And build and run, and it'll launch the emulator. What I've done is I use a text edit control to make kind of a more full-featured application that supports, so there's an about, but I can say new, and here I just threw in hello world, because why not? And I can put another line in here. I can try to close it, and it'll say, well, do you really want to do that? And I can say cancel, or I can save it, test file, and it saves, and I can open it again. And it opens. I can modify it, and I can try to close it, and I can say no, and that didn't change it. And I can go back here, I can double click that opens. I can go back here, and I can ask it to print it, which is a weird feature in Finder, and it'll actually try to, and I don't have a printer, so I'm not gonna do that. So a desktop application, pretty full-featured, and like I said, I've also got ORCA stuff. So I've got the assembler covered, I got the compiler covered, everybody's happy, right? Everybody loves ORCA-M? Correct? There's no dissent on that? Some people don't like ORCA-M. I might be one of them. I've done some ORCA-M and I'm not, but I've got something new. You like Merlin? Well, let's see what this does. So let's go back to Xcode. We'll create a new project. Well, there's something new. There's 4 new Merlin targets here. So Merlin CDA. Let's do these quick. We'll create it. Here's the Merlin assembly. Build and run that. Here's our emulator. Go to the control panel, Merlin. There we are, Merlin. So that's a CDA. Next, let's do a control panel. Merlin control panel. Merlin CDev. Here's the code for that. These are funky because the code ends up in a resource. You can build and run that. And it's right in here, control panel, Merlin. Here we can get help, and you can open it. And that's the control panel. Next one, let's do a Merlin Desktop. So this one, I don't have support, just so there's a ORCA-M. You can select the desktop resolution here. Let's do 320, because we did the other one here. But I don't have Message Center. This is a much simpler kind of template. It doesn't have a whole lot of stuff in it, but has enough to kind of get you going. Build and run that. And here's our 320 mode desktop application. And the last one I've got for Merlin is a new desk accessory. Next. Merlin, NDA. And I think I misspelled it, but doesn't much matter. And there's code. Here's the Merlin code for that. Build and run that. And there you are. So, ORCA-C, Merlin, ORCA-M, basic templates for all of them. You can get up and running pretty quick. And some of you may say, I want to use this, but I don't have a Mac. I hate Xcode. I don't know, something like that. So we can do that. I've mentioned this before, but I'm not sure it sunk in, so I'm going to show you real quick. Desk test. Oh, I've got to go in one more layer. Here, it's just make clean, make, execute. It's make. You know, if you want to do it on Linux or Windows or something that consumes make, you can. A little work. And that's it. Yes, sorry, real quick. Even for Merlin, you need Calvin Sherlock's Golden Gate because it uses the resource compiler from ORCA, and you need ORCA. So you still need it. So Ken,
where do you get it?
You get it from Ken, from Juice.js. So thank you.
Where do you get the add-ons?
Randemonium.com. Say that again. Randemonium.com with a dash between rand and emonium. I meant to mention that too. Sorry.
Next up, we have Kris Kennaway.
All right, so I'm going to attempt to explain how colors work in high-res and double high-res graphics. If you've ever played with this, you probably know there's all sorts of crazy rules about what colors you can put next to each other, and then you try and follow them, and you find that you don't get what you expect anyway because they interfere, and you get fringing and whatnot. So what's going on? So we'll start with monochrome first, and I'll start with double high-res because actually it's simpler from this point of view. So double high-res has 560 dots across the line, and in memory, the high bit of every byte is ignored. So only 7 bits from every byte map directly to 7 dots on the screen. The tricky part is that sequences of 7 dots come from auxiliary and main memory. So it goes aux main, aux main, aux main. And 40 bytes from each, 40 plus 40 is 80, 80 times 7 is 560. So in pictures, we have a byte from aux memory, we ignore the high bit, and the other 7 bits, we normally write them increasing right to left, but in screen order they go from left to right. And then following on, we have a byte from main from the same memory address, same thing, and they just lay out across the line like that. Okay, so high-res. High-res also has 560 dot resolution, but the catch is you can't turn on every dot independently. Bits 0 through 5 in every memory address turn on 2 dots, and bit 6 actually turns on 3 dots. But that third dot might be overwritten by the next byte. It's sort of stamped over the top. I'll have a picture next slide. And then bit 7 has the effect of shifting all of the dots from that byte right by 1 position. So here's a picture. Bit 7 is off here, and like before, we read these bytes from left to right to left here, but they're actually doubled, so 1, 1, 0, 0, and so on. Bit 6 is tripled, but then it's overwritten by the neighboring byte because it also has palette bit 0. But if palette bit is 1, then this second byte is shifted to the right, and we actually see that third byte. This will come important later. Okay, colors. let's think like a TV. We're going to scan left to right across the screen, and there's a color reference signal which has the same, it completes one complete phase in the same time as we scan 4 dots across the screen. So this is an analog process, it's continuous, but there's a simple way to understand this in a more binary digital format. It's only an approximation though, which is important to keep in mind. Okay, so we have 4 dots across the screen. They can have 16 values. These give 16 colors on the screen. So these are the colors you get. It's the same colors for high res and double high res, but the double high res is actually shifted left by one position because of a timing difference in the signal. You're probably thinking, wait a minute, 16 high res colors, what's going on? I'll come back to that. Okay, here's an example. So suppose we have this sequence of dots on the screen, and above it I've written the values of the clock, so that we have a clock that goes 0, 1, 2, 3, 0, 1, 2, 3. So the first dot, we have all zeros. We don't have to shift them at all to line up with the clock, and that gives us a black pixel. Moving right, we have 0, 0, 0, 1, but now we have to put the 1, which is here back in the clock 0 position. So we have 1, 0, 0, 0. That gives us this purple color. Moving right again, we have 0, 0, 1, 1. We shift the 0 and 1 back into their positions. We have 1, 1, 0, 0. That gives us violet, and so on. And this is what happens when you store a violet pixel on the high-res screen. So we see not just a violet pixel, but also some fringing either side of it. And that's what you'd see on the screen. So here's the same violet pixel. If we do the same thing for green, we again see some fringing. And if you put them next to each other, they combine to get white. They interfere. And so we get a white pixel here with some high intensity colors on the screen. Visually, this looks more like an extended white pixel, but that's an approximation here. Okay, so there's only 6 high-res colors, right? Well, if you read this, I learned this in this book, Sather, which is very, very comprehensive, also a little bit difficult to understand. You can actually get 14 of the 16 colors at byte boundaries if you do this game where you shift the palette bit and overwrite. So here's an example. So suppose we have an odd byte with palette bit turned off and the corresponding even byte with the palette bit turned on. So here's an example where this third bit, which is normally hidden, becomes visible, and if you follow the procedure before, you actually get a yellow pixel at the boundary there. So there we go. And yeah, that's all I have. Thanks. Any questions? Okay.
That was I can, thank you for that. That was the most concise explanation I've ever seen of that. That was awesome. Next we have Ivan X.
Okay, so anyway, over the last year, this is something that is only peripherally Apple II related, but it is somewhat Apple II related. Over the last year, I have gotten very into writing and composing and singing homemade music, mostly using Logic, and in particular, I have been, because Instagram, which is where all the cool kids are, imposes a 1-minute limit, I've taken to embracing that and writing 1-minute songs. So then I have to, after I produce a 1-minute song, then I have to come up with some little bit of video entertainment for it. So on a couple of those, I have used Apple II for graphics and video content. The first one I'm going to play for you is just, there's nothing very sophisticated going on here. It's just the Kaleidoscope demo from the 1979 System Master. And in fact, the Kaleidoscope on the integer disk versus the AppleSoft disk is slightly different, and there's both in there. And then there's also some editing out of the boring parts. And then the second one you will see is Prince lyrics out across the team, and the screen is literally just a bunch of print statements in AppleSoft, and then I kept trying to calibrate the speed equals AppleSoft command to regulate the flow of text to get mostly into sync with the music. So I'm not necessarily expecting you to like these. My music, for the most part, is I've been told is abrasive. So I don't think these are among my more abrasive, although the first one is a little. But anyway, I just wanted to share it with you because I was putting the Apple II to work in the service of this. This one is called Hear Me, and then after that I'll just switch over and I'll play the other one, which is called Zone Alternative. Well, you have controls over the volume, right? Martin's. Can you hear me? Can you hear me? Can you hear me? Can you hear me? At all. Can you hear me? Can you hear me? At all. At all. Thanks. All right, and here's the other one. Oh, I've gave away the end of the beginning. That's all right.
There are 26 time zones and not 24. Noon in Line Islands is Hawaii noon the day before. India and Newfoundland have special power, cause their time zone is off by a half hour. Nepal, Eucla, Chatham Island are 15 minutes off if you can find them. Arizona has no daylight savings. All these time zones, the railroads made them. Our days aren't long enough, so every 4 years we take a leap. Except once a century, that extra day the year gets to keep.
That's it. Thank you.
Yes, thank you.
Mic, but now I'm on. Okay. Let's see if this probably got it upside down. It's caught in my ear. All right, so what I have here in front of me is an Apple IIe with a super serial card and a few other little bits and bobs, but for the purposes of this demonstration, it is an Apple IIe with a super serial card and a CFFA for disk drive access. So it has a hard drive, essentially. And on top of it is my MacBook Pro. Connected between the two is, it may look like a custom piece of hardware because it is, but it's been dumbed down to be a simple USB to serial converter. So imagine a Logitech USB to serial converter, and that's what this is doing. So first of all, I'm going to fire up on my laptop ADT Pro. You can't see it because it's behind the curtain here, but that's what I'm doing. If I can find it. Yeah, window that I have ADT Pro in. And it is running the virtual serial drive, basically the server for the virtual serial drive. Which is not
There we go, okay. Virtual serial drive. And on the Apple II is the client for the virtual serial drive, which should come up right now. So I can, need the comma there. I knew I had it. There's one. And now you can see that it has, through the miracle of science, it has mounted a hard drive image that's hosted on my Mac through the serial port with the magic of ADT Pro and virtual serial drive, but that's not what I'm demonstrating. That you could do, I don't know, a few years ago. What I am going to show you, now, if I can type without seeing my screen, what I am going to show you is a bunch of garbage in the low-res screen. That's not the demonstration either. This is the demonstration. So you can see me on the screen in low res in relatively real time. Okay, so here we are in basically four colors, 4 grays. Here we go, text mode. So if I get real close to the camera, you should be able to make out my face. And I'm looking this way, and I'm looking that way. And this is all, again, through the serial port. So it's running at 115 kilobaud or whatever it is, or megabaud, 115 hertz or baud. Whatever the measurement is, it's that one. It's the high one, the most that the serial port can do. If you have a monochrome screen, this will show up. It's mapping the colors to the intensity of the monochrome colors on the monochrome screen. So instead of it being like Predator heat vision, it will look like essentially a green grayscale image in 16 colors. And what I'm doing here is cycling through the color map because I've got it optimized for, this one's for the vidHD, this one's obviously in text. It has a text lookup table. This one has a lookup table for Virtual 2, for Open Emulator, for actual hardware with a bent for the Monitor 2, I think. And then this one is color, but it's only the 3 blues, black and white. So you've got kind of a simulated grayscale there. And then, yeah, so this is going to be running on my room door now that I have a long enough cable to go out the door and hook up to the monitor there. So this is my public demonstration of my door sign, which is going to be hanging on my door. If you want to come by and make googly eyes at it or watch some of the other videos that I've actually saved to disk of various animations that'll play in this mode, I'm in 227. How am I for time? Right at 5 minutes?
Yep.
Awesome.
Yeah. You have time for a question if you want to.
I have time for one question if I want to.
So your Mac is like hammering data into the disk image, the virtual disk image?
Yes. So the what's happening on the Mac is I've got the it's trippy. I've got I've got the webcam turned on and a Python script taking frames from the video camera as fast as it can, downsampling them to 16 colors of 16 grays and to 40 by 48 pixels. And then that is getting shot through the serial port, actually is getting saved onto the virtual disk image, which the VS drive is reading over and over again the same file. And as fast as it can read that file, it's spitting bits up onto the screen. So it's doing that about, when it's, I think it's about 12 frames per second. I haven't really clocked it on in a while. That is made possible because I asked David Schmidt to turn off the caching for the VS drive server, because normally it would read the disk read the disk once and have that in memory, but I've basically turned off that caching part. So now it's rereading the disk image on this to send it. So it's sending the same block, 512 bytes at a time, over and over and over again to the serial port, because it keeps asking for that same block off the disk over and over again. So there's some heavy lifting going on the Mac, definitely, but the Apple II is doing a lot of moving of bytes around as well.
So I guess, sorry for the follow-up question, but so is the Mac opposite is not complaining about two processes trying to read the same file, or did you have to do anything special?
I didn't have to do anything special to that. The server function is basically keeping that file access open, and is keeping that file open, and Python is just streaming it into the disk, and there's no. It may need to be running at root privileges or something like that, but it hasn't complained about writing to a file while it's being read. That's probably doing terrible things to the drive, now that I say that. But no, it's fine. It's fine. It's totally fine. All right.
Thanks, Joe.
Thank you.
Next up, we have me. All right. I'm just going to tell you what happened on Lawless Legends in the last year, and you can come look at it on my screen whenever you feel like it. Here, I want to see. Wow, that was weird. There we go. Okay, lots of people have asked me what's going on with Lawless Legends. The very short story is that Seth has 2 kids and I have 1 kid. So not as much is going on as previously. The good news is essentially the game is feature complete. All the scenario stuff is done. All the game code is done. We're kind of adding usability enhancements based on feedback from our beta tester, from our alpha testers, really. Conveniences, things like that. So I'm going to demo the things that have changed since last year. Let's load a game. Okay, so you've seen this before. I made a character named Foo. One thing, so you've seen the 3D renderer and you can turn and stuff. Some of our beta testers complain that this is, yeah, it's a cool tech demo, but it's just too slow when you just want to get somewhere in town. So there's now, you can switch the movement mode to fast mode. Now, instead of doing quarter turns, you're doing half turns, and instead of doing quarter steps, you're doing half steps. We've added story mode, so for the hard drive version of the game, you won't have to look up in a paper, a paper manual. On the floppy version, it'll say read log 36, and you page over to log 36 in your paper manual, and you read this. In the hard disk version, you'll just get the whole story here. So you can move around town quickly. You can also switch it to classic move mode, where you turn a full 90 degrees with each step. And that's especially nice for beta testing, because you know where you want to go, and you have to go there over and over because there's a bug that you want to reproduce at that spot. So I tend to like fast mode now that I've played with it. I didn't think I would. Last thing I'm going to show you in the engine that's changed. Let's see, there's Marie. Let's go hear Marie's story. She's so sad and she wants her kitty. So now that we have met Marie, we can go into a quest log, Now the game is keeping track of the things you need to do. You don't have to keep track on a piece of paper all the things you need to do. Our next step is we need to help her find her cat. And you can hit S here to show. So the blinking orange and blue square is where we are. The blinking X is where we need to go. So we need to go roughly southwest. So this is a thing that games did not do back in the day, but modern players really want. And now that it's in there, I'm super happy it's there. Other things have changed behind the scene. We've eliminated a lot of super nasty crash bugs. There's now a record mode, so our beta testers can record their play session, and when it crashes, I can play the exact same thing back without using a time travel emulator, which are still kind of wonky, and I can reproduce that bug exactly. So we've squashed a lot of those, rewrote the random number generator, which was pretty terrible and now is pretty good. And the Outlaw editor has had some improvements to making graphics here, and so Seth has added a bunch more graphics all throughout the game. So we're getting close. We don't have a release date in mind. As always, our goal is to keep this fun for ourselves and also make a good game. And so I think we're accomplishing that. It's just, as you know, taking 5 years or whatever. But we'll get there, and stay with us. Any questions?
Does it take any advantage of accelerators or accelerated mode in any way?
Yes. There's been a lot of work done. So we're going to run Jace for the iOS and PC versions of this. And I'm poking special memory locations that Jace is watching for, and it turns up the emulation speed at various appropriate moments, like when the 3D rasterizer is running. So 3D mode is really quick. Also, when it changes to the various text modes, it actually shuts off the color burst on the text areas of the screen, so it's a little easier to read in emulation. That was a good question. Any other?
Will any of these improvements be incorporated into ancient legends?
A lot of the engine improvements will go straight in, obviously bug fixes and things like that. Will we go back and add quest log type stuff to it? I don't know. We could, or someone else could do it, because Ancient Legends is open source. All right, I think I've used up my 5 minutes and more probably. Next up, we have Adrian Bedard.
Okay. Hi. Is that too loud? Okay. So, hi, my name is Adrian, of course, and what I'm going to be presenting today is I'm just going to be talking about how it's fun being at KansasFest and the popular game, the popular text adventure game Coveted Mirror, and how it should help people who have hard times reading, would help them read. So I'll start with Coveted Mirror, because I know all you guys would probably like that. So why I think Coveted Mirror should be a learning thing is because I'm just going to kind of sidetrack to myself. I have a very hard time reading and writing. I don't know, it's kind of like this disability thing. And so I think differently than other people. And when I heard the game Coveted Mirror, where it was a text adventure plus graphics, I thought that was great. So I played it, and I actually learned a little bit more from that game because when people have hard time reading, they usually look at like what the picture is, and I do that in my decoding class, my reading class. And so I think it's a really a good game for people who have really bad disabilities, because if they have a hard time reading, they can just look at the screen and figure out what that was. And then I'm going to move on. Now I'm going to move on to how it's fun being at KansasFest. So if you couldn't make it this year, I'm sorry. My experience with KansasFest, it's very nice. We have a lot of lovely people here and a lot of cool people here. It's very cool to say hello to the creator of Penguin Software or Portable Software. I think that was very cool. Also, my aunt's Oregon Trail learning thing. Yeah, I thought that was also great. The food's pretty good. The food's pretty good. It's not that bad. Yeah. But I've been loving here at KansasFest. I think it's been one of the greatest festivals I've been at. And I just like hanging out with other nerds with this magical device. Yeah. Okay.
Thank you, Adrian. And last on our list, but probably not least, is Mark Pilgrim.
Okay, so two brief updates on semi-related projects. One is will serve as the official KansasFest announcement of the Wazaday project, which I started a few days after KansasFest last year, which is why this is the first time you get to see it at KansasFest. But every day since then, plus or minus a few days, I've been putting on a .waz image, which, as you may have heard, is a new disk image format coming out of the Applesauce project, which encapsulates all of the original copy protection, structural, runtime, copy protection, so you have a more authentic experience of what it was like to run the original disk without any crack screens or any additional conversions required. So we have a fair number of these now. And thanks to the MAME project and Jason Scott at the Internet Archive, you can click almost all of these and play them in your browser. I don't know if I have enough bandwidth to actually do that, but we're going to try it. Okay, so the other thing, hey, look, it's downloading. Okay, that's great. The other thing, oh my God, it's actually launching already. Okay, hey, look at that. No sound effects in the browser, sadly. But there you have it, the original copy-protected version of Hard Hat Mac in your browser from a .waz file. Okay, that's pretty cool. So the other thing is that Passport still exists, and as you can tell by the version number, this is a stable release. It was just released. The stable version, latest version, was released on June 16th of 2019, so like about a month ago. And the thing that we are cracking here is part of the Passport test suite, which is another separate set of WAS files and the DSK files that Passport creates from them, and the log files, which is the text output that it generates as it deprotects. And these are all, this is all on GitHub. It's a Passport-test suite. And it's all driven automatically through MAME with a Lua script that you can set as the MAME auto boot script, I think is the name of the parameter. But basically you can tell the MAME emulator locally, not in your browser, but locally you can say, hey, run this script, and the script takes care of reading the directory of .waz files and inserting, creating and then inserting a new .dsk file, and then literally it emu key post C to press C, and then waits for Passport to do its thing, and then saves out all the files. And so you can, in about 5 minutes, you can run through the 111 .waz files in the Passport test suite, which, and this is part of the Passport source code. This is this is the patcher for a particular nibble check, is tested on blah blah, here we go. And then if you actually go into the source code, you'll see comments like these here at this branch point. This particular WAS file in the Passport test suite has C equals 0. And at this branch point, this other WAS file has C equals 0. And so we can notate that we have code coverage for all of these different variants, all of these different possible cracks. The process of creating the test suite uncovered a whole slew of bugs, which are now fixed. So that's great. Testing is great. Passport is great. Here's all the new things, blah, blah, blah. You can download it on GitHub, blah, blah. Okay, now we're back to the emulator. Okay, crack complete. Let's go. Oh, hey, it was Choplifter. We're going to go find that disk. It was in here. And there it is. And you can mount it, and then boot the automatically cracked version of Choplifter.
That's cool.
It is not SpiraDisk, it is spiral tracking, written by Roland Gustafson. This particular module to convert, to crack it automatically was written by Peter Ferry, who is sitting in the back, who came up with a marvelous way of reusing a lot of our existing code within Passport, so we didn't have to add a whole lot of bytes just for Choplifter and the dozen or 2 dozen other disks that use the same protection. But it is completely automatic, as you just saw. And that's my 5 minutes. Thank you.